Hi, I thought today doing something quite fun. Okay, so let's explore the equilibrium points of this ball. Okay, equilibrium point is a point where if I put this little stone, it stay there. For example, if I put it right here, will it stay there? No, it does not. But what about the middle point? Yeah, so when I put it there, it stay there. So we call that point an equilibrium point. So any other point in this ball will lead the stone to move around and come to that equilibrium point. Okay, what about this part? Okay, not the inside but the outside. Let me try. I'll use a different one. I'll use this, my cat toy. Let me try to keep it. Yeah, okay. So what about this point? Is it equilibrium point? Yes, it is. It's equilibrium point. When I put it there, it stay there. Okay, you saw it. Okay. What about any other point? No, it's not an equilibrium point. Okay, so for these two points, we found two equilibrium points. For this one, which is in the right middle, and for the other one on the top. Now, let's see whether these equilibrium points can be classified as a stable point and unstable point. Let's try to figure it out. So, if I place this, let me try it. Yeah. So, if I place this close to my equilibrium point, not on the equilibrium point, but somewhere close to it, what will happen? Can you see it? Yeah. So if I put it close to it, it does come back to that stable point. It does come back to the stable point, to that equilibrium point. So this point, this point, we can call as a stable equilibrium point. What about the top point of my pot? If I put this slightly away from my equilibrium, if it on the equilibrium point, it does stay there. But what if I put it slightly away from it? Does it come to the equilibrium point? No, it does not. It goes away. So we call that as an unstable equilibrium point. Okay. So in today's lecture, we're going to explore about equilibrium points of dynamical systems. So what I talked about with these pots and everything, so they are dynamical systems. So the location of the stone placed in some point of this pot does change over the time. So it's a dynamical system. So we're going to explore the equilibrium points and the nature of their stability, stable or unstable. To do this, we're going to use a special kind of to identify this type of stability of the equilibrium point, and also to identify the equilibrium points, we're going to look at a special type of plot called the phase line plot. So there, what we're going to do is we're going to draw our timeline, because it's a dynamical system, and then we're going to figure out at what point of time it does have equilibrium point. So as we try to figure out the minimum and maximum point of a function, it's very similar to concept. So we look whether the derivative change the sign from positive to negative at a peak point or negative to positive at a valley point. So similarly, we see the change in the sign of the derivative term. And if in equilibrium points, the sign will change. And depending on whether it's going from a plus to minus or minus to plus, we can classify them as stable or unstable. So that's what we're going to explore in this class. Okay, so remember in the last lecture we learned about the logistic model. So in the logistic model, we had a value called carrying capacity. So that's the maximum amount of population that can stay in such a population model. So that is an equilibrium point, because if we start below it or above it, we saw that the population over the time change and then come back to that carrying capacity. So we can also say that the equilibrium is a stable point. What about the exploitation extinction model? It does also have similar value to the carrying capacity. We don't call it carrying capacity. And we see that if we start slightly above the carrying capacity or that number, the population grow. Or if we start slightly below it, the population extinct. So what do you think about the stability nature of that point? Okay. So extinction exploitation model does have slightly different sign compared to the logistic model. We explore that. Okay, now, and the other thing we're going to explore in this lecture is what happens to the changes to logistic models and exploitation and extinction model. So for example, let's consider a fish population in a tank. And let's say the people living around that place are pretty much fond of eating fish. So they harvest fish from that pond. Okay. So if we suppose that the fish population was originally following logistic model, it does have a carrying capacity. So what will happen now when we introduce a harvesting of fish? Will this equilibrium point change? What will happen to stability nature? What do you think? Will we have like more stable or unstable points? That's what we're going to explore. Another interesting thing that we can look at is the population, the human population that migrate from country to country. For example, in Sri Lanka, due to the past years, the economic crisis in the past years, people were migrating out to different countries in the world. So the equilibrium point that the Sri Lanka had in terms of population, what do you think? Have it changed? Should have changed? I think so. And if you think about Australia, on the other hand, lots of people migrate from other countries into Australia. That also does change the population model of the Australia. So what will happen to the equilibrium points of the populations? Whenever we have this type of like migration between countries or harvesting fish, sort of like when we introduce something, some different scenario happens. That's what we're going to explore in this lecture. I'm looking forward to see you in the class.